All right, let's take a look at more derivative techniques. And basically what we're doing when we're talking about the derivatives of the trig function is we're adding functions to our repertoire of what we can take the derivative of. But first, let's derive or find the derivative of the sine function using the definition of the derivative, the difference quotient here as h approaches 0. So I've got f of x equals the sine of x, and I want to find its derivative, and I'm going to use the difference quotient, the definition here of the derivative. Okay, let's apply that definition. So f prime of x equals our limit as h goes to 0 of the sine of x plus h minus the sine of x all over h. Okay, so in our numerator here, we've got the sine of a sum. So going back to trigonometry, angle sum for a sine, there's a nice pattern. Sine, cosine, cosine, sine. Same sign for the sine. Sine, cosine, cosine, sine. So I'm going to keep my angles the same, xh, xh, sine, cosine, cosine, sine, same sign for the sine, minus the sine of x, and we're all over h. Okay, so in our numerator we got sine x, cosine h, cosine x, sine h, minus sine x. I'm going to rearrange that so that I can factor out a sine x, which means that I'm going to commute some terms in the numerator. So I have sine x cosine h minus sine x plus cosine x sine h all over h. Okay, so now I've got a sine x here and I've got a sine x here. Okay, which tells me then I have the limit as h goes to 0. Okay, I'm going to factor out that sine x. I get cosine h minus 1. And again, that's over h here. Okay, so I factored it out just the first two terms. The second two terms have the plus cosine x sine h. Okay, and at this point, I could unadd the fractions as well. So I'm going to keep the plus here. I'll move it to the center so it looks a little cleaner here. So I've unadded the fractions in this whole numerator, keeping the first two terms with the h, the second two terms, and again with the h here as well. Okay, so once you get to this spot, hopefully you can see a couple of theorems back from limits with trig functions. Mainly, we've got this one, and we've got this one. Okay, and all of this is multiplication here, and again, I'm taking a limit. Okay, so which tells me, and again, the limit here as h goes to 0, it was cosine h minus 1 over h. The theorem goes 1 minus cosine h over h, but regardless, I would still have a negative 1 inside here, and this is going to become 0. So my next step would be that if I've evaluated the limits of each part, and again, I will separate that just so we can see. So I've got the limit as h goes to 0. I've got a sine x. I've got a cosine h minus 1 over h. Okay, and again, that's going to end up being a negative 0 if you want to think of it that way. Plus, I've got the limit as h goes to 0. I've got sine h over h times cosine x. Okay, now at this point, according to this language, h is what's changing because h is approaching 0. Okay, and as we said, a theorem back from limits with the trig, this is 0, so this first term is gone. So we end up with 0 plus, now here, you should recognize sine h over h as h goes to 0. This is 1 times cosine x. And again, cosine x in this context, in this part here, is a constant. So I get 0 plus cosine x, or just cosine x, which means that the derivative of the sine function is the cosine function. The derivative of the sine function is the cosine function. Okay,